Let's discuss the Lab 6 naive Bayes. The image displays a code snippet that is part of a larger set of instructions, likely for a Google Collaboratory Colab notebook. This specific snippet focuses on setting up access to Google Drive within the Colab environment. Here's a breakdown of the code. Asterisk from google.colab import drive. Asterisk this line imports the Drive module from the google.colab library. The google.colab library provides utilities specifically designed for Google Colab, and the Drive module allows you to interact with your Google Drive. Asterisk import OS. Asterisk this line imports the OS module. The OS module in Python provides a way of using operating system-dependent functionality. In this context, it will be used to list the contents of a directory. Asterisk hashtag mount Google Drive. Asterisk this is a comment indicating the purpose of the following line of code. Comments in Python start with a hashtag and are ignored by the interpreter, they are purely for human readability. Asterisk this is the core command for mounting your Google Drive. When you run this line in a Colab notebook for the first time in a session, it will typically asterisk provide a link to an authentication page. Asterisk prompt you to grant Colab permission to access your Google Drive files. Asterisk once authenticated, your Google Drive will be accessible within the Colab environment at the path content drive. Asterisk hashtag list files in your Google Drive. Asterisk another comment explaining the next block of code. Asterisk drive underscore folder equals content drive my drive Colab notebooks. Asterisk this line defines a string variable named drive underscore folder. It stores the absolute path to a specific folder within your mounted Google Drive. In this case, it's pointing to a folder named Colab Notebooks inside my drive. This is a common practice to organize Colab-related files. In essence, this block of code is preparing the environment for a machine learning task, specifically one involving data analysis, visualization, and building or evaluating a Gaussian naive Bayes classification model. This image shows two distinct code blocks, both related to loading and inspecting a dataset, likely for a machine learning or data analysis task. Here's a breakdown of each part. First code block, defining column names. Asterisk hashtag define the column names manually. Asterisk this is a comment. In Python, anything after a hashtag on a line is ignored by the interpreter and serves as a note for human readers. This comment explains the purpose of the next line. Asterisk columns equals pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, outcome. Asterisk this line creates a Python list named columns. Asterisk this list contains strings, where each string is intended to be the name of a column in a dataset. These names correspond to common features found in the Pima Indians diabetes dataset, with outcome typically being the target variable, whether a person has diabetes or not. Asterisk manually defining column names like this is often done when asterisk the CSV file being loaded does not have a header row. Asterisk the existing header row is not descriptive enough, and clearer names are preferred. Asterisk consistency in column names across different datasets or analyzers is desired. This code snippet performs a crucial step in machine learning, separating the dataset into features, input, and the target variable, output. It assumes that the target variable is named outcome and removes it from the main dataset to create X, the features, while isolating it into Y, the target. This preparation is necessary before feeding the data into a machine learning model. Splitting data into training and testing sets is a fundamental practice in machine learning to asterisk prevent overfitting. A model trained on the entire dataset might minimize the training data and perform poorly on unseen data. Asterisk evaluate generalization. By testing the model on data it has never seen before, you can get a realistic estimate of how well it will perform on new, real-world data. In essence, this code segment performs the following. Asterisk it prepares to use a specific type of naive Bayes algorithm. Asterisk it creates an empty learner based on that algorithm. Asterisk it then feeds the training data, x_train and y_train, to this learner, allowing the model to learn the relationships between the features and the target variable. After this fit step, the model object is now trained and can be used to make predictions on new, unseen data. In summary, this code snippet is performing the crucial step of making predictions using a trained machine learning model on new, unseen data, x_test, and then displaying the first 10 of these predictions, y_pred, to allow for a quick sanity check or initial review of the model's output. This entire block of code systematically evaluates the performance of a classification machine learning model using commonly accepted metrics, overall accuracy, a detailed confusion matrix, and a comprehensive classification report.